Okay, so now let me show you how these anomalies are created, right? We have to really configure some monitors for the system to automatically detect these anomalies. So this is my monitor UI. I can select, okay, on which database or which connection I want to create this and monitors. I can also select my database. As you can see, I was demonstrating in the Snowflake instance, I had created two databases. So this is one database. So on this database, this is the a monitor that I have already created. If you view this monitor, it will show you, okay, what is the name of the monitor, the description, the execution. So we would basically have a schedule in which we would be executing these monitors. In this case, it's monitoring, this is executing in every 1 hour, and on which asset this is there, and what is the rule that is configured. And the severity of it, right? So similarly, you can see the schema change. Schema change really has no definite rule. It is like any kind of schema changes would be detected automatically by the system. And schema change can be adding a new table. It can be existing table modification in terms of adding new column or changing data types of columns and so on. So all type of schema changes, as soon as you enable a schema change on an asset, it will capture all of those schema changes on that particular table. Let me show you how basically the form looks like. When you define a freshness monitor on an asset, it will ask you, okay, what is the severity? You can choose between critical, major, minor. Let me choose critical. You can choose what is the condition in which your freshness issue will be detected. You can see, okay, like notify when the table doesn't update in last 5 hours, for example, right? You can define, okay, now given this is my condition, in what frequency you want to check for this condition. That is where this schedule comes into play. I can say, okay, check this for every maybe 5 hours. And then you can give a name to this, like my monitor. And you can add a description for this just for your reference. And you can just go and save it. So it gets saved. As soon as it is getting saved, you get to see the name of the monitor here. And then you can always view it to see, okay, what is in there. So similarly, these are basically table level monitors, freshness, volume, and schema change. We can go to a field level monitor and we can show you that as well. So you can see, you can go to Snowflake database, this one, and I can, let's go to this table. Let's say I want to create a rule on gender code, and I want to make sure that tell me if there's a null value present in this table. So I can say, okay, check null values. I'll just copy the same description. Let's call it schedule is like 1 hour. I'll go save and next. This is where I see the rules, all types of rules. So these are different categories of rules that we support currently. We support for null values, we support for duplicate values, we support for pattern match. Within pattern match, there are different types of rules like pattern match by value or list. Similarly, there's a schema match. You can check for the matching of a schema match by data type or JSON. There is field value range match. That means you can say, okay, the maximum value of a particular column in a table should be within this range. You can do that. There are other ones like enumerations, like you have a standard code sets that you have, like gender code, for example, male and female. Now you want to check if those male and female are existing in your particular table column or not. You can do, there are many combinations are possible that you can do for enumerations, right? So these are all different types of rules that are supported. If you have any data quality rules, which is in addition to this, you can define it as a custom rules, right? So let's define null check here. I can check rule condition is equal to null, then severity is critical, save, right? So based on the schedule that we have defined, the rules will be executed in the interval. If it finds any failure, it will alert the users about that particular failure, right? So this is how basically you can ensure end-to-end data quality